Dart skill presents measures of dispersion. Dispersion measures how data values are scattered across the entire spectrum of data. Let's learn about a few ways to measure dispersion. In a data set, the range is the difference between the highest and the lowest values. So the range is the highest minus the lowest values on the data set. It indicates how wide the actual spectrum of data is. Then we have the percentile. So when we talk about the pth percentile, where p is a number, I'm going to give you an example, don't worry about that. The pth percentile is that value v such that the value v divides the data set into two parts and p% of the data is less than v. So for example, if you take a test and let's say your percentile score on the test is equal to 90, that doesn't mean that you have scored 90 out of 100 on the test or 90%. It just means that your score is in such a position when the scores are arranged from smallest to largest such that 90% of the scores are below your score. So 90% fall below your score. This is your score. So here's your score. And that's a good indication of how well you have done on the test. Your actual score doesn't have to be 90. For example, if it's a really difficult test, let's say you might have scored 50 out of 100, which is 50% of the total score on the test. And if you still managed a 90 percentile, it means that the test was so hard that most of the students who took that test struggled to get to a score of 50% that you got. Now I'm going to complete this so that somebody looking at this picture doesn't get confused with what I'm trying to say. Now I just mean that 90% of the scores are below your score. And then your actual score, so this 50% or 50 out of 100 or whatever is your actual score. And let's say this is a very hard test. Everybody has got a low score. Even if you have managed a score of 50%, you are still in the top few. And then we go on to say the percentile score, your percentile score is 90. That's how you should interpret a percentile score. And once you understand percentile, it becomes easy for me to introduce a couple of new terms. The 25th percentile the data value that has got 25% of the data below it is also called the lower quartile. The 50th percentile, this is not a percentage, I have to say this is a percentile. The 50th percentile is essentially the median. It divides the data set into two pieces so that 50% of the data is below it and 50% of the data is up. And then we have the 75th percentile. 75th percentile, again this isn't percentage is what I mean. It's percentile. The 75th percentile is also called the upper quartile. And then there's something called the interquartile range. And that is equal to the upper quartile. So it's the upper quartile, the value, minus the lower quartile. Let's look at an example to understand this better. The following data represents the weights in kilograms of a group of school kids. And here comes the data values. As you can see, they're already ranged from smallest to the largest. If it isn't, your first job is to arrange them from smallest to largest. And then go on to find the 25th percentile and the median and the 75th percentile. And there are two more questions. We're going to talk about A, B, and C first. Let's talk about B, the median. Recall that the median is the middle number on the set. Now, if the set has got an odd number of numbers, obviously there will be one single middle number. But if the set has got an even number of numbers, there are two middle numbers. So you want to take the mean or the average of those two numbers. So over here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 numbers, which means the median is going to be the mean or the average of the 10th and the 11th numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is going to be over here, the average of these two numbers. It divides the data set into two halves, 50% below and 50% above it. And the average of 58 and 58 is actually 58. So if you do 58 plus 58 and divide that with 2, you get 58. So we got the median. The median is 58. That's a good start. The 25th percentile is the median of the left half of this. So it's going to be the median of this set of data. And we have 10 of them over here. So therefore, the median of this set is going to be the of the 5th and the 6th number. So let's count them out. 1, 2, 3, 4, 5, 6. So it's going to be the mean of 52 and 53. That's 52.5. So the 25th percentile is 52.5. Done. In the same way, the 75th percentile is going to be the median of this set of data. And that's going to be again the mean of the 5th and the 6th numbers. 1, 2, 3, 4, 5, and 6. So the mean of 63 and 65 is going to be 64. It's exactly halfway between 63 and 65. And then the interquartile range is equal to the 75th percentile, the upper quartile. So that's 64 minus the 25th percentile, which is 52.5. So this is going to be 11.5. And it represents this portion of the data set, 25 percentiles on either side of the median. And then one final question to answer. What is the percentile position of the 55 kilograms weight? So if you look at this list, we have two 55s over here, 55 and a 55. So if you want to find the percentile, you want to split this up at this point so that one of the 55s would go this way and the other one goes this way. So you just split it up into two pieces, the two halves, not equal, not necessarily equal. And we already know that there are 20 data values in all. So if you count these up, 1, 2, 3, 4, 5, 6, 7. So this is 7 on this side out of a total of 20. So the percentile position of the 55 kilograms weight is going to be 7 out of a total of 20 times 100, which is 35%, which means 35% of the data are below 55.